Hi, everyone. This week in engineering, we're going to take a look at two different kinds of electric circuits. We're going to make use of our circuit simulator at bit.ly/mmr circuit. And when it comes up, you're going to be prompted with two options. The one that we usually use, you're fine with the intro. So we'll click on that. We're going to start with just a basic circuit, the one we've been making all along. I'm going to put my battery out here. I'm going to add some conductors along, one on each side. Usually when we're making a circuit, we do them like rectangles. And the reason we do them like rectangles, when we draw the diagrams for the circuits, keep everything at right angles for there. I'm going to put my load right in here. I'm going to put a light bulb right there. Keep my wire coming out. And I'm going to complete my circuit. I'm not going to worry about putting in a switch for this, because what we're going to be looking at this week is what are the differences between two types of circuits. The one circuit is a series circuit, the other circuit is a parallel circuit. We're going to use our voltmeter and our ammeter, take some measurements, and your goal for the week is to figure out what the differences are between the circuits. So right now I have a working circuit. If you ever need more space, down here in the bottom you can zoom out, you can zoom back in, whatever you need. I'm going to start by taking the total voltage in our circuit. And in order to get the total voltage, I bring my voltmeter out here. And the total voltage is always the voltage around my battery, around the source. So I'm going to take one lead, put it up here, right on that circular spot there where the connection is. I'm going to take my other lead and put it right here. And I get a value of 9 volts. So my battery is a 9-volt battery. I can change that. You can click on the battery, you can change it. I'm going to keep it at 9 volts for everything I'm doing today. So that right there is called the total voltage. That's how much energy is available for each of these little electrons as they come out. If I want to know the current, I bring my ammeter over and I place it. And the total current is going to be determined right over here as it comes out of the battery. So there's my total current. So I have 0.9 amps. If we were lucky enough to be back in class together, we'd have the simulators running on some computers. We'd have electronic parts for you to actually build these circuits. Whichever method you'd want to do in class, we'd be using to investigate. Unfortunately, since we're kind of stuck at home right now, we only have this simulator to use. I know some of my computer engineer students who have Mr. McBrien, they have different simulators you've been using. Totally fine. Use whatever you can as long as you can calculate the values that we've asked you to this week. So right now there's my total voltage and my total current. I have one load on this circuit. It's this load right here. We would call this value, I'm going to go right to it. I'm going to put my leads right around that load, so one on each side of the load coming in and out. That is called voltage 1. When it was around the battery, we call it voltage total, or VT. When it's around the first bulb, we call it V1. And the current coming out of that, right there, would be called current 1, or I1. You might be saying, hey, it's the same thing, Tolton. Yeah, exactly. If we only have one load, we only have one battery, all of the energy is being used up here. What I'm going to do, I'm going to drag this back over there, get rid of it for right now out of my way. I'm going to start to add to my circuit. Now I'm going to make what's called a parallel circuit. I'm going to throw another light bulb in here. And as soon as I add this, you're going to see something change. I've got two light bulbs. They look about the same brightness. But as the electrons come out and they go down, they have a choice of which path they go. They don't go down both paths. They have two different paths. And if I take my voltmeter and bring it over, I can do the total voltage. I could put it around the battery. I could do voltage 1, or I could do, well, what would we call it? It'd be voltage 2. And I'm not going to show you the value because that's part of what you're going to do. We call this a parallel circuit because there are two different paths for an electron to go through. This is how your house is wired. You turn on a light in one room, electricity will flow through that room. You turn on a light in the other room, it'll flow through there. If I disconnect this light bulb, I'm trying to remember how to do that. Double click and click. I still have the light in the other room. If I broke the circuit or turned the switch off in my bedroom and all the lights went off in the house, that wouldn't go over well, especially now that we're all living in our houses together. So that is called a parallel. I can keep adding more branches to it, more paths. You might be wondering, why do we call it parallel? Well, these lines in our circuit run parallel to each other, so using a math term there. What I am going to do, I'm going to get rid of this. I'm going to get rid of all of these wires, and we're going to build a different kind of circuit. It's called a series circuit. And I'm going to disconnect that, move this over a little bit, and I'm going to build this circuit so that it goes through 2 light bulbs on the same path. What I just made there is called a series circuit. You might notice something different about the light bulbs compared to before. You might notice something about how fast the electrons are actually flowing now. And if I wanted to measure the total voltage, I'd go back to my battery. Before it was 9 volts. We'll see what we get now. I still have 9 volts. But if I go around this light bulb now with my leads, I'll get a different value than I did before. So if I wanted to find the total voltage, this would be VT, this would be V1, this would be V2. And if I brought my ammeter over, the current coming out would be my total current, IT. And then if I go right here, I'd get I1. If I go right here, I'd get I2. And that's your goal for the week. You're going to actually build some circuits, some in series, some in parallel. And you're going to measure the currents and the voltage values. The big idea, a series circuit has one path only. Every single electron coming out goes through every load in the circuit. What I had before, they had different paths. It didn't have to go through each load, and we call those parallel circuits. I'm going to leave you now. I'll let you build your circuits. Ask your teachers any questions you've got as you go through. It's the only task for the week, building these circuits and calculating the values. That's all we have for this week. There's a Google quiz for you to do where we can see sort of where you're at with some of the understandings of series and parallel circuits. Have fun, engineers.